Hi, Dr. Dan here. We are going to do some a little more advanced move types now, continuing our series in getting player movement captured in Unity. So, first thing I'm going to do is let's go to our movement scene. Okay, we've got a player in there. I'm going to make a new scene. Let's call this movement advanced, and let's see, we have some prefabs built in. Let's just drag a player in, and let's make a plane. So 3D object, plane to walk on. We can reset the transform and move things around a little bit here. Alright, let's reset the transform to 0, 0. Let's pull our player down. And for the scale of the plane, we can make it a bit bigger. Let's do 5 by 5. And save. Alright, on player, I'm actually going to take off this move script and take off this rigid body, and was having a little fun and adding some shooting abilities to our player. We don't need this either. Okay, so now all we have is a fancy looking, basically, sphere with a sphere collider. Okay, so let's add a new script, and we can call this let's see, how about component movement, or component based move. Alright, let's create and add that. We're going to modify that in just a second, but the first thing I want to do is add a player controller. Character controller. And what a character controller is it's a Unity component that allows us to move a little bit easier with settings like slope limit, so we can control like how steep something is before we'll let a character move up it, step, offset, skin width, and we have some things like radius and height too that we can control on a character. And a lot of movement in games is often driven by character controllers. In VR games, character controller for like Oculus is what the Oculus player controller communicates with. So it's a good thing to know how to do movement using the character controller rather than just handling it ourselves in script. So let's modify this component-based script. All right. So of course we will need a character controller reference. Character controller, and then we'll need to grab that component. Character controller equals get component character controller. All right. Now in update, so character controller has a script, or a character controller is a script, but it has a method called move, and that method takes a vector3, which is our move direction, and we might want to multiply that times time dot delta time. So basically, we're just setting our move direction vector, and then we're going to feed it in. So we'll need a private vector here, and it'll be a vector 3, and this will be our move direction. All right, now in update, we already know how to get player input. So one way we could set the move direction is we could say move direction equals new vector 3, and we could just add our input.get axis horizontal to the x right here in the vector, and then since we're not moving up, and we can actually handle jumps if we wanted to, 0.0f, we can leave that 0, and then input.getAxis vertical for the y portion of the vector. So if we grab those every frame, we can detect if the mouse keys are being pressed, at least, or however we want to handle input.getAxis. If we have cross-platform input, we can pull from game controllers as well here. And then we want to multiply move direction times some kind of speed variable. We can set that as a public float up here, and set it initially to 5. Let's also have a jump speed and set that to 5 as well. And we'll need some gravity. So that'll be something like 20. So something that pulls us down. Alright. So that's how we'll multiply times speed there. What's wrong with this? Oh, times equals speed. Alright, so we'll multiply that whole vector times itself and speed. Let's handle jump. So if input.getButton jump happens, we can set our move direction y-axis to our jump speed. And then over time, so we'll have to check now, because we're checking for jumping. We don't want to be moving while we're jumping. So here's the cool thing, one of the many cool things about a character controller. We can just check character controller. We can just check if it's grounded right there in using the character controller, and if it is, we can allow jumping, we can allow movement. If it isn't grounded, then we'll just apply gravity. So we'll say move direction dot y, and then we'll minus equals here gravity, and we'll want to smooth that out again with time delta time. Okay, and then at the very end, we'll call our character controller move direction. So we won't allow input to change our vectors while we're jumping, but we'll call move every single frame, and that is it. That should give us gravity and pretty cool setup for just a really simple player controller script. So if I hit play now, you can see I'm moving back and forth, left and right, with just a few lines of code, and I can in fact jump. And it doesn't really matter what my character looks like, could be anything, but pretty cool. All right. So the next thing I want to look at is is movement by animation. So to do that, we're going to need we're going to need an animator controller. So I will just yeah. So what I'm going to do is I have imported just a basic prefab. Animated prefab because setting up an animation is beyond the scope of this tutorial, which is just getting movement out of Animator and then nav mesh. So 2 new components. So the first thing I'm going to do is on player, I'm going to instead of having a player here, we can, well, let's make a new scene. Keep things clean. So we'll call this move animator animation. And we'll do the same thing here. We'll make a plane. We'll reset the transform and scale it 5 by 5. Save. And then I'm going to drag this dude onto the plane so we can see him. Alright, so this guy has... The only things of interest here are that he has 2 components which we could have added ourselves, but they're already hooked up, so I don't feel like messing with them. One is an animator that has a reference to a locomotion controller. It could be any animation controller that is right here. We'll take a look at that in just a second. And the other important thing is that this is a nav mesh agent. So if we were adding these from scratch, we would just, animator would be there, and nav mesh agent would be there. Alright, so once we'd added those 2, we would then just select our avatar, which we have provided here, and our animation controller. Let's take a look at that animation controller. Alright, so if we look over here, what we have is a very simple state machine. We go from idle to move, and we do so with these 2 transitions. So if we click on idle, we can see first of all we have a animation right here, which is just our idle animation. And then when we click on the transition, if we scroll down, we can see that there's a condition added like this. And we'll take that away. We don't actually want that. The move condition is a bool, and it can be set to true or false. So when move is set to true in code somewhere, we move to this blend tree, right? And when it's set to false, we move back into idle. So let's take a look at the blend tree. So here is our blend tree. It is pretty standard for character. And what we have here are a blend tree with 2 parameters, velocity x and velocity y. And that's going to tell us which animation we're going to go towards. And these are set to positions. So the only thing we have to do is use player input or use the mouse click to determine which of these animations to go to in code. Alright, so we're actually going to do that with a mouse click. So we'll have a person running around to where we click on the mouse. But you could do this with the arrow keys as well. So that's all I wanted to say about this animator. Alright, let's add a component called move, move animation add that. And let's start editing it. We'll push things around by their animation. Second. There we go. Make it scalable. Okay. So the first thing we're going to need to do is, just as we did before, we'll need a raycast, hit, and that'll be our new raycast hit. We can set that up right away. And then we can have a Unity engine.ai.navmesh agent here. We could also declare that up here if we wanted. It doesn't really matter how you do that. We'll set our agent to get components. Unity engine.ai.navmesh agent. Like so. And then an update, we'll say if input get mouse button down 0. So if we get that right click happening, insert, then we want to do ray equals camera main screen to point ray, input mouse position, and then if we get something back, physics, raycast, ray origin, ray direction, out hit info, then we set the destination, destination equals hit point, or sorry, hit info dot point. Okay, and it's really that easy with any nav mesh agent to just set the destination to the click of a mouse. So now if we save that, switch back to Unity, go to our scene, and hit play. Set destination, agent is placed on a nav mesh. So we get an error, and the error is, hey, you have a nav agent, but there's no nav mesh. So if we click on our plane, and then click over here on static, we can add a nav, or we can, switch over to navigation and go to, so it's already selected as walkable, go to bake, and bake, and now we have a nav mesh that the agent can move around. Alright, so now if we hit play and we click somewhere, we get movement, and it's fairly smooth movement, but we're still not driving around by the animation. Alright, so let's fix that. So let's go back to our move types, and we're going to need a reference to our animator. Animator. And we'll also need a vector 2, because there's smoothing that has to happen. So we don't get, so that our animation syncs up with our transferring of positions here. And a vector 2 velocity. And this is actually going to be where we set our animation's state with. This will be our variables that we'll set the animation state with. Alright, so in start, we'll grab a reference to the animator, components, animator. And we'll say our agent.update position equals false, because we're not gonna update our position right away with this destination. We're gonna wait for the animator. Alright, so in update, after we get our mouse position, we will have a vector 3, which is our world delta position. So the change in position in world is going to be our agent, our next position minus our transform dot position. So we'll grab a reference to where we're going and then float. The difference in x is going to be a vector 3 dot product of our transform right world delta position, and our float dy similarly is going to be a vector 3 dot product of our transform forward our world delta position. Transform. Okay. And now we can have a vector 2 delta position equals new vector 2 dx dy. Alright. So now we'll want to smooth out the delta move with math f min of 1f and our time, delta time divided by something low like 0.15. And we'll smooth delta position equal, we'll lerp between those two. Vector 2 lerp. So linear interpolation means from this position we'll move towards this. From our smooth delta position we'll move to our delta position, and we'll move by the float. We'll move according to the time that is determined by our float smooth. Alright. So that's just all to smooth the animations that we're going to be triggering. So now if our time.delta time is greater than something small, we will just update our velocity. So we'll say velocity equals our smooth delta position that we finally gathered. I'll pause. Why is that not? Oh, because it's not a method. What am I doing here? Divided by time, delta time. Okay. And now we want to know if we should move. So we'll have a bool should move, and we'll just check our velocity magnitude. And we'll say if it's greater than 0.5, and our agent dot remaining distance is greater than our agent radius, so we're not where we're not at our target yet. We will we'll set this bool that we have called move to should move. So that's going to trigger whether we're going to enter the movement state in our animator. That's the key right here. So trigger animation bool to move if our velocity is great enough and we haven't reached target. And that's how we're actually moving around by the animator. We're making a trigger, and the next animation is a blend tree, the move animation. So in that blend tree, we'll set the float. Nope, set float. And the float we're going to set is called, as we saw, our velocity x, and we'll send it to our velocity.x here that we gathered in script. And we will set another float, which is called vel y to our velocity y. And that's going to tell us which of the animations in move we want to be in. Right? The blend tree will handle the rest. Okay. Now we can override here. That's all we really need to do there. We can override on animator move here, and we will say our vector3 dot position. We'll set that to our animator root position. And then we'll set this transform dot position to that position. All right, let's save that and switch back to our animator, to our to Unity, and hit play. All right, so now if I click somewhere on the scene, you'll see that we can even open up the animator when I do that. So if I click like way over here, he's going to run to that point, and you'll see in the blend tree the vel x and vel y, which we're gathering based on the point to move, are getting us there. And you see how they're kind of spinning, but we're not moving. We're in our idle state. So if we go back to our base layer, we're still in idle because we haven't gone above the magnitude that we set. So if I switch, then it's going to trigger this should move, and we'll scroll over. So there's our move condition, which is set to true. Pretty cool stuff. And that is it. That is moving now with two different things: a nav mesh agent and a nav mesh alongside an animator and a player controller. All right. If you want to pull the code for the animator that I'm using, it can be found on Unity's website in their documentation here, with a nice little tutorial that includes a lot of other stuff you might be interested in, like improving the quality of animation, looking at the target, all kinds of stuff, as well as setting this blend tree. But you can pull the the Animator controller and everything from here. So this is docs 3D manual nav coupling animation and navigation.html. I could show you. So it's inside navigation and pathfinding. That's the very last one. All right. So that is now 8 different types of movement we've included in this series, including advanced movement where you're syncing up an animator and pushing along with a blend tree. Okay, thank you for watching.